Okay, hi guys. I've been like trying to help people memorize the unit circle, in a much easier way. And if you haven't memorized it yet, I'll show you a really easy technique that my friend Sophie taught me, who's a junior. So, I'll just reteach it right now. Unit circle, it's very easy. You don't have to memorize. It seems impossible to memorize everything, but there's a really easy method. First of all, what I usually like to do is figure out the quadrantiles. I don't know what you call this, but you want to split this up into fourths. So let me find a different color. Actually, I'll use the highlighter. So fourths, and then we want to do these coordinates first because they're the whole number coordinates. We all know this is 1 and 0 because if you imagine this as a coordinate plane, then you know that will be 1 and 0. The top one would be 0 and 1. This will be -1 and 0. And this will be 0 and -1. Okay, the first step out of the way. So now we want to figure out the degrees because that's always the next easiest. So in a circle, you have either 0 degrees or 360 degrees after you do a full circle. Then that means this one, it creates a right angle. So you have 90 degrees. So half a circle is 180 degrees. Then 3/4 of a circle is 270. Then after that, our next step is just filling in the blanks. So this will be I don't know if you guys know the special triangle 30 60 90 triangle. Oh, that was a bad one. Let me redraw that. So 30 60 90 triangle. We'll get to that later, but that's how we'll label these. So it's 30 60 90. So if you look at this one, you see how it's split into equal parts right here. So this is equal. This is equal to this, which is equal to this. So basically, you just keep adding 30. So we already got 90 here, 120, 150, 180, 210, 240, 270. We already got that. 300, 330, and then 360. And then the next part is we want to figure out what this is. So in order to do that, we need to see how many parts it's split up into from 0 to 180. So we have 1, 2, 3, and 4 right here. So 180 divided by 45, which is 4. So we'll erase that. Oh, it made a straight line. Okay, so 45 is what we're starting with. Then 45, we get 90. 90 plus 45 is 135. And then plus 45, 180. Plus 45, 225. Or essentially, you can just add 15 here, add 15 here. And every time you see a big gap, you add 30. But whatever works better for you. So 315. So now we have all our degrees. So I'll change to radians now. So in case you still don't know what a radian is just the length of from the radius of the circle. So the radius of the circle and the arc length, which is right here. So the radius of the circle, whatever it is, so like I don't know, let's say this is like radius of 3 units, which means your arc length is also 3 units, and that's 1 radian. And every circle has exactly 2 pi radians. Doesn't matter how big, how small the circle is. It always has the same number. The radian is always the same. So from here, you have 0. Oh, that's my eraser. You have 0 radians and you have 2 pi radians. So very easy thing to memorize is you have 2 radians in a circle, which is 360 degrees. So that means 1 pi radian, sorry. 1 pi radian equals to 180 degrees. Because So we have, I'll explain why that is. So let's say you have, let's say the radius is like, so we know the arc length is equal to the radius. So it will always be the same. It will always divide into the same number for every circle. So we have 1, 2, 3, and like I'm not like drawing this to scale, but like it's approximately 3.4 radians in half a circle, which is 1 pi radian. And then I'll explain how we can find radians using that. So now that we understand what radians are, we'll go back to, oh, I accidentally exit out. We'll go back to finding our radians. So if you see this, I already divided it earlier, but if you look at the green part, you count that there's 1, 2, 3, 4, 5, 6. It's divided into 6 sections. So you have 1 pi radian, which is equal to 180 degrees, divided by 6. Because 180 divided by 6 is 30 degrees. And you have 30 degrees for your, okay, I don't really care about that line. So you have 6 parts that it's divided into. So that's why your denominator is going to be 6 for every 30-degree interval that you have. So at this point, we just count up. So pi over 6, 2 pi over 6, which is pi over 3. And then 3 pi over 6, which is equal to pi over 3. 4 pi over 6, which is equal to 2 pi over 3. And then 5 pi over 6, and you can't simplify that, so I'll just write that here. Then 6 pi over 6, which is just 1 pi. So 180 degrees is equal to pi radians. And then 7 pi over 6. 8 pi over 6, which is equal to 4 pi over 3. 9 pi over 6, which is equal to 3 pi over 2. So I'm just going to simplify everything. I don't want to write all that out. And then 10 pi over 6, which is equal to 5 pi over 3. And then 11 pi over 6, which you can't simplify. So now we'll go to the 45 degree. It's the same concept. So you divide it into 4. So you see you count 1, 2, 3, and 4. So from that's why we have a denominator of 4. So it's pi over 4 radians for every 45 degrees. So we just keep counting. So it's pi over 4. So this is 2 pi over 4, which is equal to pi over 3. And sorry, wait, I messed up earlier. This is actually not pi over 3. It's pi over 2. So pi over 4, so 1 pi over 4, 2 pi over 4, which is pi over 2. Then 3 pi over 4, and 4 pi over 4, which is pi. 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and we're done. So that is all our radians. And then next, we'll go to our coordinates. This is very, very easy. So if you guys know about your special triangles, to get from the shortest length, which is right here, this shortest length, and if you want to find the hypotenuse, you would do a times 2 equals the hypotenuse, right? So I don't know, let's say you have 1/2 times 2 equals 1. So, and then from basically, you'll just, okay, I don't know how to explain this, but you'll just see the 2 come into play a lot. So that's why everything is going to basically have a denominator over 2. And 1, so right here you start with 1. So what you do is you count backwards. So if you have 1, then you count from 3. So 3, and everything's going to be inside a radical. Don't ask me on this one. You can ask someone else to help you explain it. I can't explain it. I'm just helping you memorize the unit circle. So since we start from 0, we will have to do at 1. So technically it's rad 1, but rad 1 is just 1. And then we keep going around the circle. Then so we have 1 earlier. So 3, 2, 1, 0, 1, 2, 3. And then, if you remember, I said earlier, everything's a denominator over 2. Again, I can't explain this. Ask someone else. Okay, so everything is over 2 except for the 90-degree coordinates. It's just what it is. So, and then since we start from 0 at our y coordinate, in other words, our sine, we start from 1, 2, 3. Then basically you just keep looping around the circle, so just bear with me while I write this. I'm not gonna edit this. I don't have the time for that. Actually, I do. I'm just lazy as fuck. But anyway, so rinse and repeat. And then what is this? 3, 2. Oh, we don't need a radical for that. And then 1. So now that we have that, we'll have to worry about the signs next. So the way I like to think about it is, again, if you look at this as a coordinate plane, you'll know that quadrant 1 is both positive. Quadrant 2 is negative and positive. Quadrant 3, quadrant 3 is negative, negative. Then quadrant 4, oh my god, can my iPad stop being gay? Okay, quadrant 4 is negative and positive. Actually, I meant positive and negative, sorry. Okay, so now we just label our signs. This is like quite easy. You just, like I said, imagine it as a coordinate plane and then you literally have no struggle. Yeah, so like that. And then if you ever need to find cosine, sine, tangent, I'm going to switch colors again to make it less confusing. Okay, anyway, so your x value is your cosine. Sorry, I almost said sine. And then your y value is your sine. And then tangent is opposite over hypotenuse. Opposite over adjacent, I meant. Or, in other words, sine over cosine, which is equal to y over x. So let's say they ask you what's the sine of 60 degrees. This is just very commonly used. So, cosine of 60 degrees is commonly used. So I'll do that one. Cosine of 60 degrees. And we see that it's rad 3 over 2. So that is... Wait, no. I'm being gay. Okay, sorry. Hold on. So we see that our cosine is 1 over 2. And then if it asks for sine of 30 degrees, it's also 1 over 2 right there. So 1 over 2. And if it asks for tangent of... Oh, no. Let's do tan of 120. It's y over x. So 3... rad 3 over 2 divided by 1, negative 1/2, or I'm just going to times 2, negative 2. So that cancels out. But remember, we keep that negative. So tan 120 is just negative radical 3. So actually, I don't even know if that's right. So someone got to fact check me, or else I will be spreading misinformation. And then we all know about cosecant, secant, like this. Yes, we all know that. Oh. In case you don't know it, it's just reciprocal. So if you have so we know that cosine is... we know that sine is our y value. Cosine is our x value. So, and then tangent is y over x. So let's assume that we have a denominator of 1 for both. It's not an exponent. I'm just being really messy. So basically what you just do is you flip everything. Okay, I'm getting messed up by my own handwriting because it's so bad. So messy. Oh my god. Okay, so that's basically it. So knowing this unit circle, if you have one with you, or you can just fill one out on the spot, or you can just think in your brain. Okay, so if I have like sine of like 120, you can just think in your brain and you keep counting. And if you know your 90-degree coordinate is 0, 1, then you know that, oh, okay, so cosine of 120, cosine is x value, and you know that you have 0, 1. You just count back, and remember quadrant 2 is negative, and then put it over a denominator of 2. Okay, thank you for watching this video. Hope you found it helpful.